All right, so you decided that there maybe are a couple of these that you need to look over, or maybe you're just watching it to make sure that you really have a good handle on things. Either way, I'm going to take you through each one of these problems in the method that I chose. Now, if you chose a different method, you might have to come in during your own time to get your questions answered about why your method didn't work. But realistically, quadratic formula and completing the square should work for any of them. So if that's what you picked, more power to you. But for those of you that tried to factor along the way, maybe you got to one that couldn't factor, or maybe you had a little error, so we're going to get those cleared up. All right, so for this first one, I viewed this as a factoring problem. I think that's the most straightforward way to go. So I factored out a 5x, and that left me with 2x minus 9, all equal to 0. Zero product property would say that then 5x is equal to 0, and 2x minus 9 is equal to 0. It means x is equal to 0, and x is equal to 9/2, as seen below. Okay, so I think factoring is the best way to go for that one. Number 9. I again chose factoring because I looked at this and I said, is there something in my head pretty quick that I can get to 8 and multiply to 8 and add to -6? And pretty quickly I came up with x minus 4 and x minus 2. I knew they both needed to be negative because I multiplied to a positive but added to a negative. So then to solve, zero product property again would say x minus 4 is equal to 0, and x minus 2 is equal to 0, thus x equals 4 and x equals 2. So again, factoring, but that's just because I found numbers pretty quick, and I checked my work by saying x squared, -4, -2 gets -6, -4, -2 gets +8, all that internal dialogue that you should have. Remember, it's not just guess, it's guess and check, okay? And it's strategic. You're looking for things that multiply to your constant term and will add up to get to your linear term. All right, number 10, I also chose factoring, although this one I first had to get things set up a little bit differently. So I want things to be equal to 0 because that's what it means to solve a quadratic. You're looking for where this will hopefully factor or get me to 0. So looking at this, I'm looking for things that multiply to 72 because of this 6 times 12 and add to 17 because of this 17 right here. So now maybe you look at that and you're like, yeah, I don't want to do that. Great, switch to the quadratic formula. Cool, complete the square. Totally up to you. Maybe you in your head can figure out how this thing factors, okay? Personally, I need to split the middle. So I'm looking for things that multiply to 72 and add to 17. Multiples of 72 is going to be 8 and 9, which also conveniently get me to 17. So I'm going to literally split the middle term. Now, could I have split it 8 plus 9? Sure, doesn't matter. This then, 6x squared carries down, and 12 carries down, equals 0. And now I can factor by grouping. So these group together, I can take out a 3x, and I'm left with 2x plus 3. And in this purple set, I can take out a 4, and I'm left with 2x plus 3. Well, that's good, because I wanted those second sets to line up. So now this has a 2x plus 3 and a 2x plus 3, so that can come out. 2x plus 3, and I'm left with 3x plus 4 equal to 0. Zero product property, set each one equal to 0. That's where my answers are coming from. Again, if you use the quadratic formula or completing the square, you would get to the exact same numerical values. All right, this one, again, quick glance, things that multiply to -1 and add to 2. Well, in order to multiply to a negative, one has to be negative and one has to be positive. And the only ways to get to 1 are 1 and 1. So that's not going to work. I chose to complete the square for this one because I had a nice leading coefficient of 1 and my b term was even, so it just seemed pretty straightforward. So divide everything through by 1, that doesn't do anything. Move your constant to the other side. Then I'm going to take half of b, so 2, half of it, and square it, which would be the same thing as 1 squared, which means really I'm going to add 1 to both sides. So on this left side, this will factor down into that binomial squared because this is the number that I squared, so that's the number that goes here in my binomial, and all of that is now equal to 2. So to solve, I'm going to take a square root. I would get x plus 1 equals plus or minus the square root of 2. Subtract the 1, gets me to this answer. Now this one you might have also chose the quadratic formula, and you should get the exact same solution. This one will not factor for you though, at least not factoring with whole numbers right? Or our integers even, because of this irrational root 2. All right, number 12. At first glance, try to take out a GCF. Not really going to help me here. Should have mentioned that, sorry, on number 10 also. There is no GCF because 17 is a prime number. No GCF here. So I could maybe try to split the middle. I'd be looking for things that multiply to negative 44 and add to negative 4. It seems like nothing I can think of off the top of my head. So I'm going to choose the quadratic formula. Okay, completing the square would also work because we know quadratic formula comes from completing the square. The reason I'm choosing to stay away from that is because I'm going to have to divide everything through by 4. Whereas on that last one, dividing by 1, like that wasn't that hard. So I think here, quadratic formula is going to be your most efficient method. Again, if you picked a different way, but we got to the same solution, that means you're doing your math correctly, and I'm a proud math teacher. So opposite b, plus or minus the square root of b squared. I'm just going to jump to 16 because I know that to be true, and that way I don't have calculator issues. Minus 4 times a times c, all over 2 times 4. I end up with x equals 4 plus or minus the square root of 192 all over 8. So now I got to figure out, does this simplify at all? And it does. So 4 plus or minus 192 is the same thing as 64 times 3. So the square root of 64 is 8, and I get a root 3 all over 8. Now each one of these things has a 4 in it. So 4 divided by 4 is 1. 8 divided by 4 is 2. And 8 divided by 4 again is 2. This would be an okay final answer, all right? But then I chose to go one step further and write it as 1/2 plus or minus, the 2's would cancel out, the square root of 3. So these are mathematically equivalent. Either one works. All right, and that leaves us with number 13. So number 13, you could expand this out and have 49x squared minus 70x plus 25 equals 16, and then move the 16 over, and then use quadratic formula, complete the square. Maybe it factors nicely, which it does, but it might take a lot of work. The thing that's really nice here is I already have a perfect square. It's right there. So how do we undo a square in mathematics? We take the square root. So this will be plus or minus the square root of 16. Well, that means that I have 7x minus 5 equals 4, and I have 7x minus 5 is equal to negative 4. Adding 5 to the other side, I get 7x equals 9. Here I get 7x equals 1, and that's where my 1/7 and my 9/7 are coming from, respectively. Again, if you expanded that whole thing out and then subtracted the 16, you'll get to the same solution. It's just if you have a perfect square, right, this 7x minus 5 is a perfect square, might as well just take square roots. So again, in summary, you can do these ones a lot of different ways. Quadratic formula and completing the square will always work. Factoring, if you can see it pretty quickly, is a probably more efficient route. But again, it's not just guess, it's guess and check. So make sure that your factoring is done correctly before you use that zero product property. And then if you have a perfect term squared, extracting roots would be a good method for you.